So I have successive rates of change to determine whether it's concave up or concave down. Okay, so let's do, I'll just color code these. So first we'll do this rate of change. So we'll do -5 minus -8 over 3.6 minus 3. And so I got 5 for that. And then if we do this one, we'll do -3 minus -5 over 4.2. Whoops. Kind of went crazy there. Okay. So we'll do, okay, 4.2 minus 3.6. I got 3.33. And then for this one, I'll do -2, whoops, minus -3 over 4.8 minus 4.2. And so for that, I'll get 1.66. Okay, I'll do this one. So I do -1.5 minus -2 over 5.4 minus 4.8. Okay. .833. Okay. All right, so what I can see then is that the rate of change, the average rates of change are decreasing over time, are decreasing as t increases. So what that means is, if we have decreasing rates of change, that means the graph is concave down. So the next one is asking if the function is increasing or decreasing and the concavity. So it says here the number in a fish in a new pond increases very slowly after the fish are first introduced, but eventually the population starts to increase much faster. Eventually, the increase in fish population slows down as the pond becomes more crowded. So if I think about what happens, so you start out with some initial amount of fish and the population is growing slowly, then it grows faster, but as the pond becomes crowded, it goes back to slowing down. So we get something like that. And so, so it starts out to be concave up, so the graph is always increasing. At first, it is concave up when the population is increasing faster and faster, but then eventually there's a point where the population slows down on its growth, and so it becomes concave up. So at this point here is an inflection point where the concavity changes. All right, so on the next one, I want a graph of a function with all those properties. Okay, so let me erase to get some space here and see what we can do. All right, So the graph needs to have f of 0 equals 3. So let's see here. Let me look at the size. It looks like the highest x value I see is 6. So we'll graph. And the lowest one I see is like -2. Okay. So f of 0 is 3. So we can plot that point there. The solution to f of x equals 0 is x equal -2. So -2, the function is 0. Okay. It's decreasing in concave up for -infinity to -2. So decreasing in concave up. So if it's decreasing down to -2, it needs to start up here and decrease down to be about in concave up. So we've got that now. And then it needs to be increasing in concave up between -2 and 1. So increasing in concave up. So that goes like this. So we've got that. Then it needs to be increasing in concave down from 1 to 6. So here's 6. So to that, maybe I'll draw a point up here somewhere. So increasing in concave down. So we've got that. And then decreasing in concave down. So we need to keep going. So then it starts decreasing in concave down. Okay, so we've got everything. All right, next one. What is the formula for the quadratic function described in the table? Write your answer in standard form. So for this next one, I want to write a formula for a quadratic function. So we know that it looks like this: f of x is equal to ax squared plus bx plus c. So, so I know, when x is 0, those first two terms are gone. So I'm going to start by looking at this point here. So we're going to use 0, -15 here and plug that in. So, so I'm going to plug in 0 for x, and then -15 will be the function value. So -15 equals a times 0 squared plus b times 0 plus c. So that tells me that c is equal to -15, so I get that right off the bat. Another one that we might focus in on are the other ones that involve 0 outputs, because those can give us, they get rid of some of the terms, and so that's kind of nice. So let's use -5, 0 now. And so we're going to plug in -5 for x and 0 for the f of x. So we'll put in 0 is equal to a times -5 squared plus b times -5. And then I already know what c is. It's -15. So go ahead and put that in place. So we'll do -15. And then I can get an equation that gives me values for a and b. So -5 squared is 25 minus 5b and I'm going to add the 15 over. And so if I want, I can well, let's do it this way. Maybe I'll leave that 15 over there. And I can add the 5b over to the other side. So I get 25a minus 15, and then I can divide everything through by 5. I get b is equal to 5a minus 3. So that's one thing. So I have a little bit of a relationship between a and b. And then for the last point, I'll use this one because it has a 0 there. So we're going to use 6, 0, and so that gives us 0 is equal to, and in place of the b, I'm going to put this in this time. So I'm going to do a times, the x is 6 squared, plus, and in place of b, I'll put 5a minus 3, and then in place of x, I'm going to put the 6, and then minus 15. So now I have an equation that's just a, and then I can use that to find b. So I'll get 0 equals 36a plus 5 times 6 is 30a, minus 3 times 6 is 18, minus 15. So I get 66a equals, when I add that 18 and 15 over, I get 33. So I can divide it. I get a is equal to 1/2, and then I can get b is equal to 5 times 1/2 minus 3. Minus 3. Yeah. So I get negative 1/2. All right, so I'm ready to write it down. So I get, so we'll just write it here. F of x is equal to, the a again was 1/2 x squared minus 1/2 x minus 15. So there's my final answer. Okay, for the next one, find a formula for a quadratic function with that vertex passing through that point. Write your answer in vertex form. So I know that it has a vertex. So I know the vertex form is f of x equals a times x minus h squared plus k, where the vertex is h comma k. So if I can see my vertex is -6 comma 1, then my function then is f of x is equal to, we still don't know what a is, but we're going to have x minus -6, so it'll be x plus 6 squared, and then plus 1. Okay, so I'm almost there on my vertex form. Then I want to make sure that it passes through the point 2, 8. So I'm going to plug in 2 for x and 8 for my f of x, and I can get that. So I'll have 8 is equal to a times -2 plus 6 squared plus 1, and then I can solve for a. And so I can go ahead and subtract the 1 over. -2 plus 6 is 4. When I square that, I get 16a, and then I can divide that over. So a is equal to 7/16. Okay, and so now I'm ready to write it down in vertex form. So I have f of x is equal to 7/16 times x plus 6 squared plus 1. So there's my answer to that one. 21, convert that to vertex form by completing the square, then identify the vertex and axis of symmetry and sketch. Oh, so lots of steps here. Okay, so I'm going to erase this. All right. Okay, so all right, now I want to convert it to vertex form by completing the square. So we'll notice that I have a leading coefficient there on the 3, so I'm going to go ahead and pull that out. So f of x is equal to 3, and I'm just going to pull that out of the first two terms here. I'll have x squared minus, and if we do 24 divided by 3, we get 8x, and then we'll have the plus 43. Okay, and so what I want to do is I want to add in something here that makes that inside part a complete square. And so the thing I want to add in is going to be, you'll take that middle term and you want to do half of that and then square it. And that will give us something that is a perfect square. So if I do half of that -8, that is -4, and then I square that, I'll add 16. But I can't just add 16 out of the blue. I have to also subtract it off because I need to kind of add 0 in a creative way. But if I think about it, that's not just a 16, it's a 16 times 3, right, that I have added there. Because I've added that 16, but it's inside of those parentheses that's being multiplied by 3. So when I subtract it, I need to subtract off the 3 times 16. And 3 times 16 is 48. Okay. And so now I've got an equivalent function written down there, and I can go ahead and factor this inside part, and we'll notice that it factors to x minus 4 quantity squared. So if I factored that, I'd get x and we get minus 4, 4. So it factors into x minus 4 quantity squared. So I'm going to write it down like that. So we've got 3 times x minus 4 quantity squared, and then when I add those two things together, I'm going to get minus 5. So that's my f of x. Okay, and so when I look at that, I can see my vertex sitting there because it's in vertex form. So my vertex is equal to 4 comma negative 5. So that's my vertex. And so this is an upward facing parabola with vertex 4, negative 5. So 1, 2, 3, 4, 5. So the vertex is here. That means the axis of symmetry is x equal 4. And then if I want to sketch a graph of my function, I can go ahead and do that. One thing I like to do when I sketch a graph is I just go ahead and plug in x equals 0 to see where the y-intercept is. That just kind of gives me an idea of another point on my parabola. And so if I plug in 0, I get 3 times 4 squared is 16. And then minus 5, I get 43. Oh, goodness. Okay, so it's going to intersect the y-axis up at 43, so we'll just kind of go like this, and it's going to be a really skinny one. So that's probably good enough. All right.